Hello students, welcome to the fourth video of revision series. In this video, let's revise some descriptive questions based on the chapter electricity. Before going to the questions, get ready with the notebook to note down the questions and to solve the answers along with me. Note down the first question. The current flowing through a wire of resistance 2 ohm varies with time as shown in the figure alongside. Calculate the amount of heat produced in joules in 3 seconds. The graph given alongside gives you an idea of the current flowing through the resistance wire for each unit of time. Let's assume that the time is 1 second. So we can calculate the heat for each 1 second and just sum it up to find the net heat produced in this resistance wire of 2 ohm. So we need to find the heat produced in the graphical sections of AD, DG and GJ. For AD, the current is 3 ampere, resistance is 2 ohm and time is 1 second. The formula to calculate the heat produced in a current carrying wire is I square RT. Let's substitute the values. I square is 3 into 3 which is 9 into 2 into 1 which is 18 joules. So the heat produced at AD is 18 joules. Now let's calculate the heat produced at DG. For DG, the current is minus 2 ampere, resistance R is 2 ohm and time T is 1 second. We are going to take the same equation, H is equal to I square RT. Substitute the values. So I square is minus 2 the whole square which is 4 into 2 into 1, 8 joules. So for DG, the heat produced is 8 joules. For GJ also, follow the same method. Here the current is 1 ampere, resistance is 2 ohm and time is 1 second. On calculating, you get that the heat produced is 2 joules. Now to find the total amount of heat generated, add all the 3 values. Therefore, total heat produced is 18 plus 8 plus 2 which is 28 joules. Question number 2. You are given n identical wires, each of resistance R. When these are connected in parallel, the equivalent resistance is X. Calculate the equivalent resistance when these resistances are connected in series. First, let's calculate the equivalent resistance when these wires are connected in parallel. So let's draw the circuit. There are n resistors of resistance R and they are connected in parallel. How will you find the equivalent resistance in a parallel connection? Yes, we take the sum of the reciprocal of the individual resistances. So 1 by Rp equal to 1 by R1 plus 1 by R2 etc. up to 1 by Rn. Now all the values are R. So it will become 1 by Rp equal to 1 by R plus 1 by R plus 1 by R etc. up to 1 by R for n times. Since all the values are same, it will become 1 by Rp equal to n into 1 by R which is n by R. So Rp equal to R by n. From the question we know that the value of Rp is X. So X equal to R by n, or the value of R resistance is Nx. Now the second part of the question says that these wires are connected in series. So let's draw the circuit. So all these resistors are connected in series and the value of each resistor is Nx. How will you calculate the equivalent resistance here? Just add the value of the resistances. So R equivalent equal to Nx plus Nx plus Nx etc. up to n times. Since all the values are same, it is n into Nx, or the equivalent resistance is n square x. So the answer for this question is n square x. Moving on to the third question. 2 wires of resistances 2 ohm and 4 ohm are connected in parallel to a 220 volt supply. Which among the two resistors dissipates more power? In order to understand which resistor dissipates more power, let's calculate the power dissipated by each resistor. So power in 2 ohm resistor will be P is equal to V square by R. Substitute the value, you will get 220 square divided by 2. That is half into 220 square. And power in 4 ohm resistor will be 1 by 4 into 220 square. So this shows that the power is dissipated more in the 2 ohm resistor. Also, let's recall that power is inversely proportional to the resistance. So in a conductor, if the resistance increases, the power decreases. Next question. Find out the following in the electrical circuit given. Effective resistance of two 8 ohm resistors in combination, current flowing through 4 ohm resistor, potential difference across 4 ohm resistance, power dissipated in 4 ohm resistor, difference in ammeter readings if any. Let's name the resistances. Let R1 be 8 ohm and R2 be 8 ohm. both these resistors are connected in parallel. So the effective resistance will be 1 by Rp equal to 1 by R1 plus 1 by R2, which is 1 by 8 plus 1 by 8, that is 2 by 8. So Rp equal to 8 by 2, which is 4 ohm. Second question, current flowing through the 4 ohm resistor. Let R3 be the 4 ohm resistor. We have already found out the effective resistance of the two 8 ohm resistors. So notice the change in the circuit. Now the two 8 ohm resistors have been combined and it has become Rp. Since these two resistors, that is R3 and Rp, are in series, so the current flowing in the circuit will be the current through the entire circuit. Hence let us use the formula I is equal to V by Rs. Why we take Rs? Because there are two resistors in series, and since the current is flowing through the entire circuit, we have to find the total resistance of the circuit. So 8 by R3 plus Rp, that is 8 by 8, which is 1 ampere. So current in the entire circuit is 1 ampere. Question C, potential difference across the 4 ohm resistance. Since R3 and Rp are connected in series, it means the voltage difference or the potential difference across these three resistors will be different. So we can use a direct formula, V is equal to I into R3. V is equal to IR is the Ohm's law formula. Since here it is potential difference across the 4 ohm resistance, so the value will be 1 into 4 is equal to 4 volt. Power dissipated in 4 ohm resistor. The formula is direct. P is equal to I square R. Substitute the value of I, which is 1 into 4 watts. Difference in ammeter readings, if any. You can see that both the ammeters are now in series. So the same current flows through both the ammeter, and hence there will be no difference in the reading of the ammeter. Question number 5. The figure below shows 3 cylindrical copper conductors along with their phase areas and length. Compare the resistance and resistivity of the 3 conductors and justify your answer. Electrical resistivity is the measure of a material's ability to oppose the flow of current. We know that the formula is R is equal to rho L by A, where R is the resistance of the material, rho is the resistivity of the material, L is the length of the material, and A is the area of the material. So let's find the resistance of all these 3 cylindrical copper conductors. For the copper conductor A, since the length is L, the formula will be R is equal to rho L by A. For B, the length is 3 times the original length, that is the length is 3L and area is A by 3. So substitute 3L and A by 3 in the formula R is equal to rho L by A. So it will become rho into 3L divided by A by 3. So if you have a fraction in the denominator, you have to take the reciprocal in the next step. It will become rho into 3L into 3 by A, or 9 rho L by A. Already we know rho L by A is R. That means for the second conductor RB, it is equal to 9R. That means 9 times the resistance of the first conductor. Similarly, let's find the resistance of the third conductor. For the third conductor, length has been reduced to L by 3 and area has been increased to 3A. Substitute these values in the formula. So RC equal to rho into L by 3 by 3A. When you have a fraction in the numerator, take the fraction to its appropriate form. That means that 3 will come into the denominator part. So it will become RC equal to rho L divided by 3 into 3A, or 1 by 9 rho L by A. That means for the third conductor RC, it will become 1 by 9 times of the original resistance. This means that the resistance is minimum for the third conductor and maximum for the second conductor. So will be the resistivity also. Next question. In an electrical circuit, 2 resistors of 2 ohm and 4 ohm are connected in parallel to a 6 volt battery. Heat dissipated by the 4 ohm resistor in 5 seconds will be. First, let's draw the circuit. So it's given that these 2 resistors are connected parallelly to the source. So what's given here? R1 is 2 ohm, R2 is 4 ohm, time taken is 5 seconds, and potential difference V is 6 volt. We know that in a parallel connection, the voltage is same across each the component. So we can use the formula H is equal to V square by RT. Substitute the values V square, R and T. We get 6 into 6 by 4 into 5, which is 45 joules. So the heat dissipated here will be 45 joules. If in the same question, instead of parallel, if it was series, then we know that in a series connection, the voltage is not same. Only the current is same. So we can find the current for this circuit and then we can use the formula I square RT. How will you find the current? We know that according to Ohm's law, I is equal to V by R. But here there are two resistors. So we have to first find the total resistance. R is equal to R1 plus R2, which is 6 ohm. So I is equal to 6 by 6, which is 1 ampere. Now substitute the values in the formula I square into R2 into T. Why are we taking R2? It's because in the question we have been asked to find out the heat dissipated by the 4 ohm resistor, and here 4 ohm is R2. So after calculation you get the answer as heat H is equal to 20 joule. A student carries out an experiment and plots VI graph of 3 samples of nichrome wire with resistances R1, R2, R3 respectively. Which of the following is true? R1 equal to R2 equal to R3, R1 greater than R2 greater than R3, R3 greater than R2 greater than R1, or R2 greater than R3 greater than R1. First, let's try to understand the graph. From the graph, we can understand that maximum current is recorded for R1 and minimum current is recorded for R3. We always know that current flow is always inversely proportional to the resistance. That means if there is maximum current, it means the resistance is minimum, and if there is minimum current, it means the resistance is maximum. So R1 having maximum current will have least resistance, and R3 having minimum current will have maximum resistance. So the option correct is R3 greater than R2 greater than R1. So I hope that you have understood the 7 problems that we have discussed in this video. Check for the link of the playlist of Physics and Chemistry chapters term 2 of class 10 in the description. Also check the other videos of revision series, it is part 1, 2 and 3 for more questions. Let me wish you all the best for the upcoming term 2 science board exam and let you all perform well. If you like this video, hit the like button and share the video among your friends. Also subscribe the channel for more contents of class 10.